Okay, we go for the example. So this is a simple example. So you need to determine the input impedance of the circuit given, and your omega is actually equal to 10 radian per second. Alright, so how we want to do this? Alright, so first thing first, we know that this is an AC sorry uh, uh, we are in AC circuit analysis. So first thing, you need to convert all the element into a Passer form or Passer domain. So therefore you are given omega equal to 10 radian per second. Alright, so you have 2 millifarad over here, and then you also have 4 millifarad over here, and then you also have 2 Henry over here. So all these element you need to convert into a Passer form. Alright, so therefore we convert this element first into a Passer form. So for 2 millifarad, so the value of the value is given by 1 over the formula is actually 1 over j omega c, and then is equal to 1 j omega equal to 10, and then c equal to 20 milli over here. So therefore you got 1 divided by j, right? 10 times 20 milli is equal 0.2, and then we know that by bring the j into the upper position, so you got 1 divided by 0.2 is equal to alright, is equal to so this one is not 0.2, sorry, this is not 0.2, is 0.02. So therefore 1 divided by 0.02 is actually 1 over j50 sorry, okay, sorry, j is we bring it back to the upper side, it become negative j, and then 1 divided by 0.02 is actually equal to 50. So therefore 2 millifarad is equal to negative j 50 ohm, right? So this one is equal to j 50 ohm, right? So next you have 4 millifarad. So we do the same thing. So just convert this one into a 4 millifarad over here, right? So the value of C become 4 milli. So in here you have 4 milli. So therefore 10 times 4 milli is equal to 0.04. Okay, 1 divided by 0.04 equal to 25. So therefore for 4 millifarad, so the value of the impedance is actually negative j 25 ohm, right? So this one is negative j 25 ohm. And then net you have 2 Henry, right? So 2 Henry, how to get the value of 2 Henry into a Passer form, right? So because it's a capacitor, so therefore j omega L, we are using this formula. So j omega is 10, and then your L is 2. So therefore for 2 Henry, the Passer form is actually equal to J20. So the impedance, right? So J20 ohm. Alright, so now we already convert all the value into a we call it into a Passer form. So then we can do like a normal DC analysis. So in order to find the input impedance, so if you see this circuit, so we are looking from this terminal. So therefore we can say that this one and this one, this impedance impedance is actually are connected and in parallel, and then you have another impedance over here, right, is connected in series, right? So therefore you need to find the parallel impedance over here, then you need to add with the impedance over here because they are connected in series, right? So therefore let me show. Okay, let's say I segment this one into one element because they are both are them in series. So I can represent this one by a 20 minus J50, right? You got here over here, and then this part you only have a capacitor, so therefore is equal to negative J25 ohm, and then this part you have a 50 plus J20 ohm, right? So therefore this part and this part for I can say that is Z1, I can say this Z2, and then I can say this one as Z3. So if you see from here, Z2 and Z3 are connected in parallel. So therefore by using a normal parallel formula, so actually you can say is that Z's parallel equal to Z2 times Z3, Z2 plus Z3, right? So just put all the value, right? Z2 is negative J25 over here, and then Z3 is 50 plus J20 ohm over here. So do the mathematics, right? So let's say we don't have enough space, but can do here. So Z2 is negative J25 times with 50 plus J20, right? And then Z2 is negative J25 plus with 50 plus J20. So solve this one using the calculator, and then what you got is actually, please check by using a calculator. So therefore is equal to 12.38 minus J23.76, right? So ohm. So the parallel impedance is equal to 12.38 minus J23.78 ohm. So therefore we know that this parallel, okay, this parallel part actually now in series with the Z1. So therefore our next step is actually to calculate overall value. So therefore we can say that Z in equal to Z parallel plus Z1, Z1, right? So Z1, this is your Z1. So therefore it's equal to 12.38 minus J23.76 plus with 20. This one you got I think we got minus J50, right? So therefore by using the calculator, so at the end you got 32.38 minus J37.36. So this is our input impedance. So remember the unit is actually in ohm. So therefore what we can say that actually we can use in AC analysis, in order to solve the circuit, or in order to do the analysis for the circuit, we apply the same rule in DC. But the only things that you need to do first is actually to convert all the element into a passive form. Then only then you can apply whatever rules that we or theorem that we apply in a DC circuit, right?